So we can start with this paper. This is 1-3, October 2021. Okay, this is we're going to try and do an MCQ paper. That's so the first question. Okay, he's talking about the mass spectrum of neon and the relative abundance of each peak. So how do you figure out the relative atomic mass? Kya karte hain? You just what do you do? He's saying the relative abundance. Actually, one thing, be very careful in this question whether this is percentage or abundance, because over here the formula of AR is it's percentage, I mean over 100 into the isotopic mass. So you have to multiply the percentage abundance and you have to sum them all up. That will give you the average. So over here, what is the percentage, fractional percentage of the isotope which has a mass of 20? That is 100 out of, what is the total? That's I think 108.3. So the first one, it's 100 over 108.3, and you're going to multiply it by the isotopic mass, which is 20. What is the other one? That's 0.3. It's not 0.3%. Okay, remember that. It's 0.3 out of a total of 108.3. And that's going to be into 21. Plus, it's going to be 8 over into 22. Okay, you find that and you'll get it. What's the answer for this? You can just be careful about this. You can make sure that if it's not percentage, calculate the fractional percentage. Okay, what do we get for this? Mikal, Minahil, anyone? Saimik here. So 168. So that's coming out to be A. Next one, 2 grams of ammonium nitrate decomposes to give 0.9 grams of water and a single gas. What is the identity of the gas? So you've got NH4, NH3, and he's saying it produces water, and there is some gas which is X, and you have no idea what that X is. And they're asking you to figure out the identity of the gas. So this is going to be 2 grams. What we can do is, so this is going to be 2 grams. And this one over here is 0.9 grams of water. So what I can do is I can figure out the mole ratio between them. So it's going to be 2 divided by what is the MR of this? That's going to be 62 plus, I think that's 80. You what 60? The N is 14, 14, 28, and 48 plus 4. So I think that's going to come out to be, I think it's going to come out to be 80. That's my moles. 2 divided by 80, which is what? 2 divided by 80, that's probably going to be 0.025 moles. And we can figure out the moles of water as well. That's going to be 0.9 divided by the MR of water, which is 18. So if I do that, so I think that's going to be 0.05 moles, right? 0.9 divided by 80. So now what I have is I have the mole ratio. I know that how this equation is balanced. The mole ratio is 1:2. So that means 1 NH4NO3 is producing what? It's producing 2 water molecules. Okay, now I have a balanced equation, and the rest is X. So what could be X? Now this ratio is like, we know the real ratio, it's 1:2. So if I subtract 2 water molecules from that, so 2 oxygens are gone. So what am I left with? I'm left with 1 oxygen. So I'm only left with 1 oxygen. And 2 water molecules of 4 hydrogens. So 4 hydrogens are gone. So what am I left with? I'm left with 2 Ns. So the formula of whatever X is, that's going to be N2O. Okay. So that is going to be N2O. Ye clear? Achha, agla part, which of these elements has the highest 5th ionization energy? So 5th one. Even in the data booklet, you just have 4 ionization energy. So the highest 5th ionization energy is probably going to belong to which element? It won't be phosphorus and it won't be silicon. Because if you try to remove the 5th electron from phosphorus or sulfur, remember phosphorus has an electronic configuration of 2, 8, and 15 electrons, right? So that's 2, 8, 5. So if you're trying to remove the 5th electron would be removed from the outermost shell, which is the 3rd shell. So it would be kind of easy to remove electrons because it's really far away. Silicon, it's going to be 2, 8, 14 electrons, right? So it's going to be 2, 8, 4. So if you're trying to remove the 5th electron, you're removing it from the 2nd shell. So silicon will have a higher ionization energy compared to phosphorus because the electron is much closer to the nucleus. The 5th one. Okay, carbon is going to be the answer because if you try to remove the 5th electron, nitrogen is 2 and 7. So if you're not 2 and 7, it's actually 2 and 5. 7 is the total number of electrons. So if you're trying to remove the 5th electron, you're removing the 5th electron from the 2nd shell, which is again further away from the nucleus. And in the case of carbon, it's 2 and 4. So if you try to remove the 5th electron, you're removing it from the 1st shell. So it's going to be the hardest. Smaller atoms always have higher ionization energy. So the 5th electron is going to be removed from the shell, which is right next to the nucleus. So that's why that will have the highest ionization energy. 5th one. Okay, the next one is the ion X plus 2 has the same electronic configuration as the krypton atom. What is the electronic configuration of an atom of X? So we're going to look at the krypton atom. Not sure how many. I think it's got 36 electrons. So 36 electrons will have an electronic configuration of, I mean, it's going to be 1s2, 2s2, 2p6. 3p will be full as well, and then there's going to be 4s2. So is this 36? I don't think that's 36. 1 second. Actually, I would need a pure table for this. 1 second. This is 36. One thing you can do is krypton is in the one. It's in the 4th period, and krypton will have the 4th shell would be completely full. So to get to 36 electrons, what you'll have is you get the electrons. That's 4, 10, 12, 18, and 20, which is 20. So there's going to be 4p6. And even the 4d will be full. Okay, so the entire 4th shell would be, and that's how you reach. Does that make it 36? Yeah, it was 20. Now that's 36. So you're fine. You're at 36. And sorry, 3d10 tha, not 4d10. I missed the 3d. Anyways, you'll have 3d10, 4s2, and 4p6. So the way you write electronic configuration is argon is up till 18. So you're gonna make that argon. Okay, so this part 18. This is argon. 18 electrons, and after that you're going to have 3d10, 4s2, and 4p. 4p6. So which one is the correct one? Achha, now the other thing, that's the krypton's electronic configuration. And you have the ion, which is +2. And he's saying it has the same electronic configuration as krypton. So that means the ion has lost 2 electrons. So this one over here will have an extra, if you're talking about X will have an extra 2 electrons. So what comes after 4p6? It's going to be 5s2. Okay, that is what comes out after 4p6. You would have to make the table over here to just check, because you're going up till, you would have to double check this one. I mean, we've got 5s, 2p, 3p, 4p, and 5p. I mean, you can't do this with memory because you don't remember that much electronic configuration. So as you got 1s2, 2s2, 2p, 3s, 3p, 4s, and then there's going to be 3d, 4p, and 5s. So 5s comes after 4p. So X has 2 extra electrons. So the correct answer would be B. Okay, so and just remember, okay, krypton had the same electronic configuration as X +2 ion. So the atom X will have 2 extra electrons. So I added 2 extra electrons to that. Achha, which type of interaction exists between water molecules and metal cations in aqueous solution? Kya hoga? What's the answer to this? You got a metal ion and you've got an aqueous solution that has, let's say you have water, it obviously has water in it. So what type of attraction would exist if you have an aqueous ion floating around in water? Obviously, guess karo, what would you have? It's going to be an ion dipole attraction. I mean, you got an ion and you got a very strong dipole, negative, and this is positive. So the dipole is going to be attracted to the positive ion. You just have to guess this. You haven't studied this, but you just have to make a guess. In reality, this is actually the end of forming a dative bond, because the electrons in a dative bond, you have lone pairs being donated by one atom in a bond. These lone pairs will be attracted to the positive ion. So there's going to be a dative bond that would exist eventually. Like in yahan pe, they're just looking for the interaction, like what sort of interaction would they have? So which substance shows the greatest deviation from the properties of an ideal gas under room temperature? So anything that has a lot of intermolecular force, that will have the greatest deviation. So which one has the highest? That's going to be ammonia, because ammonia has hydrogen bonding. In order to determine the enthalpy change of neutralization of a strong acid and strong alkali, this much as NaOH and hydrochloric acid, the increase in temperature is 12. And then there's a second experiment. The same method is used, but 50 CMQ of this and this are mixed together. What is the increase in temperature in the second experiment? So let's look at the first one. How many moles do you have? What is 25? I mean, the first one, you have NaOH reacting with HCl. So in the first reaction, how many moles of NaOH and HCl are reacting? That's 25 into 2 divided by 1000. What do you get? That's 0.05 moles. So 0.05 moles react with 0.05 moles, and there's a temperature increase of 12 degrees centigrade. So there's an increase in temperature 12 degrees centigrade. Now you have another one where the next one, I think they've doubled the moles. So now you have 0.1 moles reacting with 0.1 moles of this. So the amount of water that's going to be produced when an acid and base react, that's going to be double the amount. So the increase in temperature is going to be for 24 degrees centigrade, because you've doubled the amount of reaction, that you've doubled the amount of products that are forming. So it's twice the amount of reaction. 0.05 reacts with 0.05, that's 12 degrees centigrade rise in temperature. If there's another 0.05 reacting with another 0.05, I mean, you've doubled the amount, so there's going to be another increase of 12. So the total temperature rise would be 24. Because is it going to be 24 or not? 1 second. You've doubled the amount, but you've also doubled the volume as well. So just 1 second, let's calculate. I'll check the answer as well. Let's calculate Q is equal to MC delta T. Now it's a solution. It's 25 cm³ mixing with 25 cm³. Now listen to this question very carefully. So the mass of water is going to be, you're mixing 25 cm³ in the first experiment, you're mixing 25 with 25. So that is 50 grams because water solution has a density of 1. Specific heat capacity is 4.18. And delta T is 12. Now that releases a certain amount of energy, and that certain amount of energy is, what is that? That's 50 into 4.18 and multiplied by 12. That gives you 2508, right? And that's going to be in joules. So that's the first experiment. Now in the second experiment, you've doubled the amount of moles of acid, TK, of acid and base. You've doubled the amount of moles of acid and base. So the amount in the second experiment, that's experiment number 1. So in the second experiment, experiment number 2, the amount of heat produced or the amount of energy produced would be double the amount. So you double this 2508, that would give you what, 5016 joules of energy. So in the second experiment, based on the idea that you have doubled the moles, the amount of heat energy that's going to be produced is going to be double the amount. Now, in this question, they're looking for the temperature increase. Now we know that, let's do the second experiment. It's going to be MC delta T. Now the volume is bigger as well. The second experiment, it's a much bigger volume. It's 100 cm³. So it's going to be 5016. 100 cm³ solution is equal to 100 grams into 4.18 into delta T. So if I do the math and try to figure out what delta T is, what do I get? It's 5016. Second. Because I'm again getting 12 degrees centigrade. Now the reason behind that is, even though you're producing double the amount of energy, and you're going to be producing double the amount of energy because you're adding double the amount of acid and alkali. So the reaction will produce double the amount of energy, but the law is that you got a bigger container, you got a bigger solution, it's going to take a longer time for it to heat up. I mean, like if you put water on a stove, you got a smaller solution, its temperature rises very quickly. And if in the bowl you have a much bigger solution, its temperature would take a much longer time to rise. So even though the heat energy produces a lot more, it's double the amount. Lekin at the same time, the volume of the solution is also double the amount. So 12 degrees centigrade is going to be the answer because the temperature would rise exactly the same. Okay? Is that clear?
Sir, so we don't need to do this all calculations. Like, can we directly do the same temperature?
No, you would have to do the, क्योंकि वो तो इसमें करके पता लगा है ना, you did this और फिर you figured out कि it's the same temperature, right? So you would have to do the calculation. Start with हमने बड़े naively कह दिया था ना कि if the number of moles are double, so the temperature rise would be doubled. But then we realized that no, that's not how it works. I mean, the heat energy produced would be double, not the temperature rise. Because the heat energy also depends on the mass. It also depends on the specific heat capacity and the temperature change. So we know that the heat energy is going to be double, not the temperature change that's going to be doubled. ठीक है, तो वो calculation से पता लगा temperature change remains the same, right?
Okay, sir.
So now this one is chromium is reduced to chromium 3+, which equation is correct? Zinc 2+, zinc atoms can be oxidized to zinc 2 plus. So, and chromium is going from, so all you need to do in this is you need to balance the redox equation, number of electrons gained and lost, they have to be equal. So chromium is +6 and chromium is +3 over here. Zinc is 0 and zinc is +2 over here. So zinc loses 2 electrons, right? While chromium gains 3 electrons, so it gains 3 electrons. But there are 2 chromiums in the equation, so that's a gain of 6 electrons. So zinc should be losing 6 electrons. So zinc should be multiplied by 3. So there should be 3 Zns. There should be 2 chromiums and 3 Zns. I mean, if you balance the number of electrons that are lost and gained, so again, carefully, it's chromium is +6 and it goes to +3. So that's a gain of 3 electrons. And since you have 2 chromiums in the equation, so that's a gain of 6 electrons. Zinc goes from 0 to +2, it's a loss of 2 electrons, but it should be losing 6 electrons. So I would have to multiply that by 3. So there should be 3 Zns and 2 chromiums. Okay, clear? So C would be the balanced equation electron wise. Okay?
Yes, sir.
As of the next one, you've got H2 and I2 react to form an equilibrium mixture, or it's an exothermic reaction. The mixture containing equal amounts of H2 and I2 is made at temperature T1. And the composition of the mixture is monitored. A graph shows the results. So a mixture containing equal amounts of H2 and I2. So at the end of the day, as the experiment is repeated at a lower temperature, which new graph would be obtained? First thing, if you have a lower temperature, which one would be favored, forward or backward at a lower temperature?
Forward.
Okay, forward exothermic is favored at lower temperature. Exothermic is going to be favored. So what would be the mole fraction of I2? There would be less I2, right? So moles of I2 or mole fraction of I2? I2 decreases. Okay, is that clear? Because the I2 gets used up. So Pele mole fraction was 0.23. Now the mole fraction is going to be, why is it still 0.23? The mole fraction, 1 second. Previously the mole fraction was 0.23 and actually, sorry, the graph is going down. So the mole fraction is going to be less than 0.23. And let's just be clear whether the mole fraction is going to be less than 0.23 or not. Okay. I mean, definitely is going to be, because there's going to be less I2 and there's going to be more HI. So the amount of moles of I2 in the container would be lesser. So the mole fraction of I2 is going to be lesser. So the answer is going to be B. Okay, the mole fraction would be less than 0.23. There's going to be less of I2. Plus, the equilibrium is going to take a longer time to reach, because if you're at a lower temperature, the concentration would keep on changing. It's taking, this is the point when equilibrium is reached. Okay, when equilibrium reach hota na, what happens is that the concentration of the reactants and products, it becomes constant. Okay, so yahan pe mole fraction of I2 became a constant. So that kind of indicated that the equilibrium has been reached. But if you're doing it at a lower temperature, then it's taking a much longer time for the equilibrium to be obtained. ठीक है, clear है?
Yes, sir.
अच्छा, फिर ये कि you've got which change to the diagram occurs if an effective catalyst is added at the same temperature. So if you add a catalyst, what will happen? I mean, there's only one thing. The shape of the graph remains the same. This is your activation energy E, I think. The value of the activation energy decreases. That's it. More particles will, 1 second, more particles will possess higher values of E. No, they won't. The graph would remain exactly the same. The only thing that will happen is that this activation energy would decrease. That's about it. You will have the activation energy at a much lower value. So which element requires the least number of moles of oxygen for the complete combustion of 1 mole of its atoms? We'll just I mean, this part is all inorganic. So which one would require the least number of moles of oxygen for the complete combustion of 1 mole of its atoms? So you would have to make equations for this one. And remember, he's talking about 1 mole of atoms. So you'll first make a balanced equation. So it's going to be 2Al. Okay, 4Al hoga, and there's going to be 3O2 and 2Al2O3s. And you're going to go for 1 mole of atom. So if I want to make aluminium as 1 mole, so this is going to be divided by 4. This would be divided by 4 as well, and this would be divided by 4 as well. So यहाँ पे you're getting to burn 1 mole of aluminium atoms, you would need 0.75 moles of O2, 304. फिर magnesium का कर लेते हैं. You've got magnesium and you're reacting it with oxygen and it's producing magnesium oxide. You have to keep magnesium as 1 mole, so it's going to be half O2, right? So that requires 0.5 moles. Phosphorus, what do you do with phosphorus? That's phosphorus plus oxygen ends up producing P4O10. So you're going to have 4 P's and 5 O2s. फिर इसको भी करना है कि you have to make it 1 mole, so it's divided by 4. Divided by 4, that gives you 1.25. So the amount of oxygen is 1.25. And sodium is going to be, it's going to be Na2O. 2 and 4, divide everything by 4 so that sodium becomes 1. So it's going to be 1 by 2. So anyways, so kya question? The least number is 0.75. This is 0.5 moles of oxygen. This is 1.25, and I think the least is for sodium. That's 0.25. So D is your answer. Or element Y reacts according to the following sequence. So it burns in O2, forms a white solid, then reacts with HCl and forms some random solution, and then you add NaOH, it forms a white precipitate, and in excess of NaOH you get a solution. And you have a white precipitate, it dissolves. So this, I think, is going to be, it's going to be aluminium, because you're going to get aluminium oxide. That's a white solid. You react it with HCl, it's going to form AlCl3. Now, the test for aluminium ions is that if you add NaOH, it forms a white precipitate. And later, when you dissolve it in NaOH, the precipitate dissolves and it forms a solution. So remember this, if I open the inorganic notes, you should know the test for cations and anions as well. Okay, ये वाला है. ठीक है, एल्यूमिनियम का टेस्ट है. ये बिल्कुल बॉटम पे है इसका. So aluminum has a test which is, निकाल तो नहीं दिया उन्होंने. As the first one. So look at the NaOH test. It's a white precipitate which is soluble in excess. So that is the second part. Okay, you had a white precipitate that was forming with NaOH. So that is definitely aluminium. And that is soluble in excess. So इसी से पता लग गया था कि this is a test for aluminium. So aluminium is going to be your, it's going to be your answer for this. ठीक है. तो ये इसका और ये वाला clear है? ये बस याद रखना, even though a lot of people are skipping out on P3 practicals, but remember the test for cations and anions have to be memorized. In which list are all 3 compounds soluble in water? So again, solubility table. So calcium carbonate is not soluble. Calcium hydroxide is also kind of not soluble. Magnesium is soluble as sare. I mean, chlorides are mostly soluble except for silver and lead. Hydroxides when barium hydroxide is soluble. Sulfates when magnesium sulfate is soluble. Magnesium hydroxide is not soluble. Carbonates are not soluble. Calcium hydroxide is even partially soluble. Strontium carbonate is not soluble. So next one, there's an anhydrous magnesium nitrate. It decomposes when heated, giving a solid and a mixture of two gases. What is the ratio of the mass ratio? Okay, so you have to calculate the mass ratio. So what are the two gases that are going to be formed when magnesium nitrate decomposes? It will form magnesium oxide plus 2NO2 plus half O2. So second, why is oxygen? So the other gas is X, and you have to find the ratio of the mass of X and the mass of Y. So what is the mass of X? Okay, if I go with 2NO2, that's 2 molecules of NO2. What is the mass? 14 plus 16 into 6 plus 16, that's 46. So that's going to be 46 into 2. 46 into 2 is 92. Or half oxygen molecule. What's the mass of half oxygen molecule? That's 32 divided by 2, that's 16. So this is the ratio that you're getting, 92 ratio 16. And there's another problem, okay? This part was easy, that you had the mass of, you had to just figure out the ratio of the mass of X and the mass of Y. Now, the other trick that they played in this question was that they gave the ratio in this weird form. Okay, the numerator has to be 1. So I need to make the numerator as 1. I mean, I would have to do some math as well. So how do I make the numerator 1? I'm going to divide both things by 92. The top one would be divided by 92 and the bottom one would also be divided by 92. In that case, the numerator would become 1. It would be, the top one would be 1. The bottom one would be 16 divided by 92. If I do that, what is 16? What do you get 16 divided?
So it's 0.174.
ठीक है. तो बस ये था कि उन्होंने आंसर ना स्ट्रेट फॉरवर्ड नहीं दिया हुआ था. They just I mean, you had to do some math to get the answer in that form. I say in a series of 9 experiments to test the reactivity of the halogens, what happens to the reactivity of the halogens? Does it increase or decrease? Top ones are the most reactive, right? And what is the rule? The most reactive one displaces, when I end with this iodine. So the rule is for the elements, the more reactive displaces the less reactive from its solution. So your top wale, these are the more reactive ones. So the first experiment, if you add chlorine to sodium chloride, nothing would happen because, I mean, it's pointless. Like chlorine will not, I mean, you're going to get the same thing. Like if you react chlorine with sodium chloride, even if chlorine displaces chloride, it's going to give you the same thing. There's no reaction, right? So this chlorine that's added, and remember, chlorine is a greenish yellow gas. So this case, when I remember this, the solution will have Cl2 gas, Cl2 aqueous, sorry. Is that clear? Because you added Cl2 to NaCl and nothing happened. So the solution has Cl2. There's no reaction going on. Next one, Cl2 reacting with Nabr. So what happens here? Cl2 is more reactive. So what will it do is it's going to displace Nabr. It would form NaCl, which is colorless. And bromine liquid would be produced. There's your second experiment. At the end of the reaction, there's going to be a reaction in the second experiment. And the solution will have Br2 liquid. Up the third one, again, there's going to be displacement. There's going to be Cl2 reacting with NaOH. And NaCl would be produced and the iodine will get displaced. So iodine would be formed in this case. So pehle mein to chlorine वैसी पड़ी होगी by default because there is no reaction happening. So you are adding chlorine, so there is chlorine. As a bromine pe aa jao, bromine will, if you add bromine to NaCl, nothing would happen. So the solution will just contain bromine, Br2, because there is no reaction happening. Second one, if you add bromine to NaBr, again, there's not going to be any reaction. So the solution will contain bromine because there is no reaction happening. In the third one, bromine is more reactive than iodide, so there's going to be displacement and iodine would be, it's going to be formed. So okay, third one, iodine is not going to react with any one of them. Okay, iodine is less reactive than chloride, so it's not going to displace it. Iodine is less reactive than bromide, so nothing would happen. Or iodine or iodide is a very pointless reaction and nothing would happen in that case as well. So every time you add iodine, iodine just remains part of the solution. So मैंने वो लिख दिया कि at the end of the day, what would the solution contain? जिनको मैं tick करूँ, that is where the reaction happened, right? So there were only reactions happening in these three.
Sir.
Huh.
Sir, why not in experiment 4, like Br2 is less reactive than Cl2? Like,
ये वाला?
yes, sir.
Br2 is less reactive, so there's not going to be any reaction, no displacement reaction. कुछ नहीं होगा ना. Br2 will not be able to displace NaCl. क्योंकि less reactive है ना.
Oh. Okay, sir.
ठीक है. Remember, more reactive displaces the less reactive. ठीक है. तो अगर कुछ होगा नहीं, तो that means कि you added bromine and that bromine is just part of the solution. There is no reaction happening. ठीक है. मतलब इन सारे experiments में ना no reaction happened. And I also gave you the picture of what is left in the solution. So the 9 resulting mixtures are then shaken separately with an equal volume of hexane. The 9 tubes are left to stand so that the aqueous and organic solvents separate into layers. So how many test tubes contain a purple upper hexane layer? So purple means which one is present? If you're talking about a purple layer, so purple kya hota? That's iodine, right? So at the end of the day, in all of these experiments, iodine will be present and the answer would be 5. In 5 of the solutions, you will have, at the end of the day, whether there's a reaction or there's not a reaction, iodine is going to be present. Is clear? And the trick was they weren't really interested in whether there's a reaction happening or not happening. They were just interested in if you add iodine to NaCl, obviously no reaction will happen. So the iodine is just part of the solution. So the iodine is still part of the solution. You add iodine to NaBr, obviously no reaction happens. So the iodine just remains part of the solution. Iodine to iodide, again no reaction. यहाँ पे क्या हुआ था कि bromine, if you add to sodium iodide, iodine gets produced after a reaction. ठीक है. तो इन दोनों में iodine was produced as a result of a reaction. In these three, the iodine was by default just present in the solution because there was no reaction happening and you were adding iodine. So इसलिए चलो ये कर लेते हैं. Z is a compound of sodium, chlorine, and oxygen. It contains 45.1% by mass of oxygen. Z is prepared by reacting sodium hydroxide with chlorine, which shows that the conditions used for the reaction and the oxidation state. So you have to memorize this. Chlorine with NaOH. There are two reactions. One is if you reacted with hot NaOH, it produces NaClO3. If you reacted with cold NaOH, chlorine, it produces NaClO. All you have to figure out is they told us that the compound 45.1% by mass of oxygen is present. So I'm just going to try and figure out who has 45% by mass of oxygen. So this one looks to be the one. Okay, kitne oxygen? That's 16 times 3. What's the total mass? That's 23 plus Cl is 35.5 and plus there's 16 into 3. I mean, you do the math is into 100. So what is the percentage by mass of oxygen? That I think comes out to be RF 45% के लिए. किसी ने किया? I mean, just by basic math, like I mean, you can make a guess even. कि वहाँ पे the oxygen mass is not, it's not even close to 50%. Like Na is 23, Cl is 35.5, so that's like 50, and oxygen is just 16. So
Yes, sir. It's coming out 45%.
ठीक है, तो इसका मतलब है कि it's this one. So in this question you didn't actually have to do some math on this. You just have to figure out कि cold NaOH के साथ में ये बनता है, hot concentrated NaOH के साथ ये बनता है, so इसके साथ ये बनता है, उसका वो बनता है. वो बस देखना था कि किसके अंदर 45% है. So it's this one. So it's going to be hot concentrated, and the oxidation state of Cl is going to be +5. I mean, you can just calculate the oxidation state. That is +5. ठीक है, ये बस जल्दी से 19 और फिर 20 कर लेते हैं. ये तो आसान है. Ammonia molecule, what's the shape? Ammonia has one lone pair, so which is why it looks like a pyramid. And ammonium is the same thing, except कि वो जो ऊपर lone pair नहीं है, that is bonded datively to an H+1. So that is tetrahedral. So one of them is pyramidal and the other one is tetrahedral, and they all have sigma bonds only. सारे bonds जो है ना single bonds हैं, so they're all single bonds are sigma bonds. अब फिर describe two environmental consequences of adding too much ammonium nitrate. Increased plant growths in rivers, so that is a fertilizer. So that is a consequence, and photochemical smog is not a consequence of that. So B, photochemical smog जो है ना वो दूसरी चीजों से, nitrogen car exhaust, nitrogen oxides, it's because of that. ठीक है, चलिए ठीक है, यहाँ पे फिर खत्म करते हैं. ये फिर कल कंटिन्यू करते हैं. ठीक है, चलिए, ओके देन, टेक
I
केयर.
love it, sir.